Hello students, so in this video we'll go for the next point from the topic straight line is angle between lines. If we have any angle which if those two lines are not perpendicular to each other, then we can find the acute angle between those two lines if the slopes of those two lines are known. We'll see proof of results in this video. Now I'll go for the next theorem. That is, if theta is acute angle between two non-vertical lines, again the line should not be parallel to y-axis, then if slopes of these two lines are m1 and m2, then tan of theta, that is theta is acute angle between them, is mod of m1 minus m2 divided by 1 plus m1 m2. In two different cases we can see this. These two cases are very interesting, so we'll see proof that. Now we have considered those two lines L and M. I will name them as L and M there. This is the line L, this is the line M. It makes angle alpha, inclination alpha, and it makes inclination beta there. Same for line L in the second case. This is alpha and this is beta. So for line M. So alpha is inclination for line M. So slope of L is given by m1 and it is tan alpha, and slope of this line M is m2, this is tan of beta. So we'll consider this as first. Okay, now see what is the difference between these two. We have considered these points as A, B, C. A is the point of intersection of these two lines in both the cases, and the first line L intersects at C and second line intersect at B. Okay, so see the angle BAC here, it is acute angle. In the first case it is acute angle, and second case angle BAC is obtuse angle. So we are considering theta as acute angle. So in the first case angle BAC itself is theta, but in the second case angle BAC is not theta because it is not acute angle. So acute angle will be theta on this side, and so measure of angle BAC is equal to 180 minus theta, that is pi minus theta. So measure angle BAC, this acute angle between those two lines, is either theta or measure angle BAC is equal to pi minus theta in first and second case. So by exterior angle property in triangle, this is exterior angle property in triangle. What we are getting, see the difference. Alpha is equal to beta plus theta in the first case, or we are getting alpha is equal to beta plus pi minus theta. And so we will find the value of theta there. Theta is equal to, it is alpha minus beta on this side, or now bring this, take this minus theta on other side. So we get it as theta is equal to pi minus. Now you are getting this beta minus alpha, or taking minus sign common, we may write this alpha minus beta. Just we have obtained the value of theta in both the cases. Then we'll take tan ratio on both sides. So tan of theta is equal to tan of alpha minus beta in the first case, or in the second case we get tan of theta is equal to tan of, this is pi minus alpha minus beta. Okay, and you see what is allied angle for me. Tan of pi minus any angle will be minus tan of that angle. So this is minus tan of alpha minus beta. So tan theta is either tan of alpha minus beta, or tan theta is equal to minus tan of alpha minus theta. Why this is so? Because see, theta is acute angle. Acute angles means it is in between 0 and 90. So if the angle is in between 0 and 90, its tan ratio will be obviously positive because tan is positive in first quadrant. So LHS of both the results are positive. Now RHS, here we can see alpha minus beta. The difference is acute angle because it is theta. But here the alpha minus beta is that angle pi minus theta, and it is obtuse. So it should be negative. And so negative of negative ratio will be positive. So in both the cases, though we are getting LHS positive, RHS should be positive. So tan of alpha minus beta is there. And because of this minus sign outside, again we are getting the positive term. So mathematics or the result itself takes the care of sign here. Then, now if we combine these two results, see what happens. Tan of theta is equal to, if it is positive, then we'll consider tan of theta. If it is negative, tan of alpha minus beta, then we'll consider its negative to make it positive. And this property can also be satisfied by one operation. It is known as modulus operation. So tan of theta is equal to mod of tan of alpha minus beta. What happens in modulus? If it is positive, it keeps it as it is, and if it is negative, it will consider its negative, which is the positive. And now we'll use the formula for tan of alpha minus beta. This is tan alpha minus tan beta is divided by 1 plus tan alpha into tan beta. This is the formula for tan of alpha minus beta. And see what is tan alpha and tan beta. We have denoted tan alpha is equal to m1 and tan alpha beta is equal to m2. So we can use here tan alpha, this is m1 minus tan beta is m2, is divided by 1 plus tan alpha is m1 into tan beta is m2. And so we are getting the formula as tan of theta is equal to mod of m1 minus m2 divided by 1 plus m1 m2. And this is the formula for acute angle between any two lines if their slopes are given as m1 and m2.